Today we're talking about proving triangles congruent, and we're going to start with the side-side-side postulate. It says if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So you notice in this particular example here, AB is congruent to DE, AC is congruent to DF, and BC is congruent to EF. So we can make the statement that the triangles are congruent, and we can say that triangle ABC, make sure that we've got the right sides corresponding. AB corresponds to DE, and remember that AC corresponds to DF, so C and F will have to occupy the last positions. So we can make the statement that triangle ABC is congruent to triangle DEF using that side-side-side postulate. Let's move on. The side-angle-side postulate. It says if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. And in this picture I've illustrated, we have side QR and MK that are congruent, side RT and KL that are congruent, and the angles in between them are also congruent to each other. That would be angle R and angle K. And so we have side, angle, side, side, angle, side. And so we can make the statement that triangle QRT is congruent to triangle MKL because of the side, angle, side postulate. Now let's look at these examples that follow. What I'd like you to do is to state whether or not these triangles are congruent, and if so, why. Well, it looks like we have all of the corresponding sides congruent to each other. XY is congruent to TS, XZ is congruent to RS, and ZY is congruent to RT. So those are congruent by side, side, side. And let's also write a congruence statement. So triangle XYZ, we're going to start with that, is congruent to, well, which side corresponds to XY over here? It has the three marks. Well, it looks like TS corresponds to that. And we do want this to go right around. So we have ST, and then we have YZ with the two marks, and so then we have TR with the next two marks. So it looks like we're going to say triangle STR. And let's just double check and make sure that works. So XY corresponds to ST, YZ corresponds to TR, and then lastly XZ corresponds to SR. So those are congruent by the side-side-side postulate. Next, we're given this particular diagram. We're given these two triangles that share a side, and we're given this right angle. Well, if we have a right angle here, we also have a right angle on the other side. So those angles are congruent. Since they share the side, that side is congruent in each of the triangles. And it looks like these two triangles are congruent by side, angle, side. Okay, and if we actually want to give a name to these, let's do it X, Y, Z, and T. Let's see if we can actually name those triangles. So it looks like triangle X, Z, Y would be congruent to triangle T, it looks like would correspond to X, Z corresponds to Z, of course, and Y, of course, corresponds to itself. So triangle XZY is congruent to triangle TZY. Now let's label these triangles as well. So let's call them K, T, X, J, and M on these vertices. Now, are these triangles, two triangles, congruent? Yes, they are, because look at this. You might be wondering about these angles, but they're vertical angles, and vertical angles are congruent. And so it looks like we have side, angle, side, side, angle, side. And so let's write out a congruence statement. So we're using side, angle, side. And it looks like triangle KTM is congruent to, well, it looks like X corresponds to K, T of course corresponds to itself, and M corresponds to J. So KTM corresponds to triangle XTJ. Let's move on. We're going to use our postulates to do some two-column proofs here. And we're given some information. I know we've done these before. And we're going to list statements and reasons. So we're given the segment AB is congruent to segment CB. So I'm actually going to mark that in my picture. And we're given that D is the midpoint of AC. And we want to prove that triangle ADB is congruent to triangle CDB. So let's start by writing down our given information. We're given that AB is congruent to CB. And the reason is it's given. Our next statement is that D is the midpoint of AC. The reason is it is given. That was just information that we had. Now let's think about what we know. Well, if D is the midpoint of AC, wouldn't that mean that AD would have to be congruent to DC? Isn't that what the definition of a midpoint means? That you divide a segment into two equal segments? So what we're going to do is we're going to make the statement that AD is congruent to DC. And the reason is because that's what the definition of a midpoint says. That just, since D is the midpoint, AD has to be congruent to DC. Now, so we've got two sides equal. Now, we can get third sides equal as well, because look at this. The triangle, each triangle shares the same side of BD. So in BD is congruent to BD in each of those triangles. So we're going to write that down. Segment BD is congruent to segment BD. And you remember what that's called? When anything is congruent to itself, that's called a reflexive property. Now look at this. We've got all three corresponding sides congruent to one another. That's all we need to prove a triangle congruent, because we've just used side, side, side. So our last step is to write down what we were trying to prove. Triangle ADB is congruent to triangle CDB by the side, side, side postulate. Okay, so now let's move on. Let's try another one. You are given the information in this diagram that segment AB is congruent to segment CD, and that segment AB is also parallel to CD. So we've got those marked in the diagram. And what we want to do is we want to prove that triangle ABC is congruent to triangle CDA. So let's write out our statements and reasons. We'll start with all the given information. So we're going to say that AB is congruent to CD, and the reason is it is given. Secondly, segment AB is parallel to segment CD. The reason is it is given information. That's what we started off with. And now let's think about it. Statement 3. We know that these two lines, AB and DC, are parallel, and we know that they are cut by a transversal right here. And so when you have two parallel lines cut by the transversal, we know that the alternate interior angles are congruent. So we know that angle BAC and angle DCA must be congruent. So let's write that down. Angle BAC is congruent to angle, let me get this down again, DCA. All right, and that is because they are alternate interior angles postulate. Okay, that's the one that says that if you have two parallel lines cut by a transversal that the alternate interior angles are congruent. All right, so now let's see what we've got. Now, we've got a side and an angle on each triangle that are congruent. Now, notice the triangles share a side. That's CA. So CA is going to be congruent to CA in each triangle. And if something's congruent to itself, that is the reflexive property. And so now notice in each triangle we have side, angle, side, side, angle, side. That's all we need to prove the two triangles congruent. So triangle ABC is congruent to triangle CDA by side, angle, side. Now let's move on to the next page. You are given this picture that ST is congruent to UR and SR is congruent to UT. And I'd like you to prove that triangle SRT is congruent to triangle UTR. I'd like you to see if you can do this on your own, and this is what we'll go over when we come to the next class. Thank you for joining me.